Hi, my name is Dahlia. I'm going to be explaining the mission context and settings, as well as the methods and instruments for the Jezero crater exploration. The main goal for the exploration was to explore as well as preserve the habitability and history of the crater, search for signs of past life, and prepare samples to return to Earth. The study setting was targeted on a cluster of rocks exposed in the Nervetta Vallis, the feeder channel for the Western Fan. The Bright Angel Formation was found to have distinct mudstone conglomerate outgroups, and that was the main part that was investigated. The Bright Angel Formation is interpreted to have formed some sedimentary processes, including deposition from water, which came from fallout from suspension, and that formed mudstone and current formations. Methods and instruments include the planetary instrument for X-ray lithochemistry. This used micro X-ray fluorescent elemental analysis on the crater, and this was used to map chemical enrichment and provided data such as the size for the crystallites. The Sherlock, the scanning habitable environments with Raman and luminescence for organic chemicals, was used for detecting organic matter using deep ultraviolet Raman spectroscopy. The super camera was used for remote sensing and spectroscopy. It indicated that the Bright Angel rocks were weakly hydrated. The radar imager for Mars subsurface experiment was used by penetrating the ground and investigating structures and layers.
Hi, I'm Clarissa. I'm going to be continuing the video to go on to our key scientific findings. So, organic matter was detected in Bright Angel mudstone targets and the strongest signal found in the Apollo Temple. And the mudstones with organic carbon have two features that formed after the sediment was laid down, the authigenic nodules and reaction fronts, circular spots. So the nodules and reaction front rims are enriched with Fe, P, and zinc, Zn. Their chemical makeup suggests that a FeO to P ratio of about 2 to 3, matching minerals related to iron phosphate minerals formed by oxidization. And the central part of the reaction zones contain high levels of sulfur, iron, nickel, and zinc, and their Fe to S ratio is close to 3 to 4, this which fits the mineral rate. The study found that as the amount of oxidized iron in the mudstones increased, the level of reduced minerals like vivianate and I don't really know how to say that, and the SHERLOC Raman G band signal. So number 4 is an exploration of reaction mechanisms. So for the Vivianate formation, the initial state, the original sediment oxidized and contained an Fe3 plus and phosphorus. And phosphorus was likely to be absorbed on Fe3 plus, rich in sediment grains, and reductive dissolution, oxidation of organic matter along with reductive dissolution of Fe3 plus in the sediment grains is responsible for the Vivianate formation. And precipitation, this process liberates Fe2 plus and PO4 3 minus into solution, which precipitate as vivianate. And the conditions, this transport and precipitation occurred under non-oxidizing conditions and the moderate pH, which prevented the mobilization of Al3 plus and favored vivianate formation. And I'll let my partner continue from here.
Hi, my name is Haley, and I'll continue the presentation. This next slide is called an exploration of reaction mechanisms. So in the null hypothesis, it suggests that non-biological chemical reactions created the reduced minerals in Jezero's crater under low temperature conditions. And it explains that abiotic organic carbon compounds, either formed on Mars or delivered from space, can promote the reductive dissolution of ferric ion oxides at lower temperatures. The reduction of sulfate to sulfide by organic matter is very slow, below 150 to 200 degrees Celsius. And to reach temperatures above 150 degrees Celsius, the rocks would need to be buried to depths of around 5 kilometers. And side note, however, the bright angel formation shows that no evidence of deep burial or heating, making this high temperature process highly unlikely. So it's hard for it to reach the higher temperatures, meaning that the process is very slow. Alternative hypothesis that was proposed was that the biological process could have driven the formation of reduced minerals. On Earth, Vivian by Vannet noludes form as the byproduct of microbially mediated iron reduction in freshwater and marine environments. The iron sulfide mineral aggregate often forms through microbial sulfate reduction and is commonly found near Vivanti deposits. Minerals created through iron and sulfur-based metabolisms are some of the earliest known chemical evidence for life on Earth. These are the same types of features in Jezero crater, which may therefore represent potential biosignatures. In this scenario, oxidized iron and sulfate act as electron acceptors for organic matter oxidation, leading to the formation of iron phosphate and from iron reduction. And then iron sulfide from sulfate reduction is also formed. Next, I'm going to go ahead and go through the pictures that we created. So we all use ChatGPT to create our pictures. This first one, it's a model of the orthogenic noludes, which are the small, round little dots that you see here. This next picture is the instrument that's used for the X-ray pictures. And then this final picture is just a picture of the crater. And then that is the end of our presentation, and thank you so much.